Hello everyone, my name is Ömer Çolakoğlu and I am a Microsoft Data Platform MVP from Turkey. Today, I will talk about query optimization and techniques about improving SQL Server query performance. At first, I want to apologize my poor English and I will try to use basic words and sentences. I hope you won't be bored. SQL Server is really skillful software and the main point is to know how SQL Server engine works. The SQL is the global language for all databases, but T-SQL is the native language of SQL Server. If you are good at T-SQL, you can rocket your slow queries even 1000 times and more. Let me introduce myself. I am from Turkey and I am a data platform MVP with 4 ranks. I have 21 years experience with SQL Server and I am an IT manager of a private company. I am an instructor and trainer on some online education platforms such as Udemy for 8 years. I have more than 400,000 students in these platforms and I am a community lover. Let's look at the desk in front of us and check what we have. Today, everything is changing so fast. We have Azure, Fabric, AI Copilot, ORM tools, data science, Power BI, Snaps, Fabric, etc. And a lot of subject launching day by day. Let's look at the reality. We have an unchanging concept, performance. It is always the main subject of data. Because data is growing so much, SQL language is the most important skill for data users for more than 50 years. So if you know the SQL and T-SQL so good, you will be happy even those new techniques and concepts. So what the performance mean? For the end users, the performance means the screens which shows so fast and we can say that the query duration is a measure, but not only think about the performance. As DBAs and DB developers, we have to check other values for the performance, such as read and written page counts, memory usage, CPU usage, etc. You will see some wise sentence at the left of the screen like this. There is no absolute rules in SQL Server. There are always a benefit, cost calculations, options, and choices. They belong to me and it will help you to understand the SQL Server philosophy, and I call it SQLism. Let's talk about how can we improve the SQL Server performance. Here is the flow. Measure, check, determine the problem, develop a solution, try and fix. What we need: index management, query optimization, system configuration to have knowledge about SQL Server objects. Today, I won't talk about the system configurations. Let's underline the index management topic. We have some questions. Should we use clustered index? Yes, actually, we can say that we should. Because the clustered index means the physical allocation of the data. And other indexes reference to this index. Other question is which data type we must choose, identity integer or the global unique identifier. I think using the identity integer value is more than effective than QID. It depends on your data scenario, such as microservices, but generally using the identity field is important for the performance. By using identity field as clustered index, you guarantee no fragmentation because every new row is written to the end of the data. So the order will never broken. Other question is how to order composite indexes. For example, you have a query and you have 4 conditions at your where clause, where name surname like David and birth date 1987 and state equal Arizona and city equal Phoenix. And for this query, which index we should use, and if you use composite indexes, but what is the order of these fields? State, city, birth date, name surname, or city, name surname, birth date, state. We have 24 different options with for factorial. The composite index or included column. Our aim is to decrease the page read. So we have an index with the name surname column, but we want to select the ID, name surname, birth date, and the city columns too. So then we have two options: a composite index with the union of ID, name surname, birth date, city fields, and other options is an index with name surname field and including ID, name surname, birth date, and city fields. We can choose the second option. The index has the included columns because we don't need any other operations, the column included columns, and the option is more efficient than the first one. Clustered column store index is the other wonder of the database world, but most of the people don't know this type of index. It is more usable for data warehouse systems. I have a demo with 50 million rows data with clustered column store index. Let's look at the performance tips. Don't use union. I see the union word in lots of environments, especially in views. I can just say that it is a real performance killer. We can use alternatively temp table and store procedures. We can insert data from different tables or queries to temp table instead of the union or union all. So it's natural alternative to union. Don't use views in user-defined functions. Views are so useful objects. They can simplify the query and architecture. The queries with 10 joins are not easily readable, but a view is very readable. I see these are useful, but this gives us a bad habit of using views everywhere because they make us lazier. We start to use views in user-defined functions. We join views each other and create a new views, and we combine views with union or union all. I just want to say that these are performance killers, and if you are using views like this, you are the murderer of your database. So please use row queries in user-defined functions. If you need, use force index. Sometimes SQL Server cannot find the right index for the query. A lot of things can be caused for this case. Don't waste time trying to find why. If you trust your index, you can use force index with hint. Avoid distinct and count in big tables. And also I see distinct word in a lot of places. When asked the developer, why are you using the distinct command? The answer is, sometimes I am getting repeating rows with my queries and I want to make sure that my rows do not repeat. I'm asking again. You are writing more than 100 queries and maybe just 2 or 3 one has repeating rows, but you write distinct word for your all queries. It's crazy. And if your query includes repeating rows, then you must find it the reason of the repeating. The distinct mustn't be your solution because the distinct is an extra process for the results. And yes, the cost of the distinct is very much, and it is a real performance killer too. You want to learn about the row count in table. If your table is big table, then and count function takes time to get. You can use some alternative ways such as sp space used or sys dmdb partition stats, and don't use function in where condition. It is very common to use. For example, you want to select people who born today from 10 million rows data table. The first technique is most people's brain is using datepart functions, but this way is a disaster because the system cannot use the indexes and scans all the table. And also, this situation is valid for the other functions such as is null, left, substring, or any other user-defined function. Check the page you read. The performance indicator is not only duration, but also read page count is a very important indicator. For example, you write a bad query, it works and duration is about 2 seconds. But if you investigate the page count and you see the reading page is about 1 gigabyte, then you have a problem. If you have 50 concurrent users, then so yes, you are in trouble. We have demo for this situation too. Be careful with triggers. They are natural part of the transactions. We can use triggers for some situations after delete, update, or insert. We have a table, delete trigger, to delete data to another table. Think about this situation. In this situation, any field in log table gets an error divided by 0 or string or binary data is truncated, etc. So what happens? 1. The data in main table will be deleted and nothing will happen in the log table. Second, the data in main table will be deleted and you get error in log table. Third, nothing will happen for both table. The answer is 3. Yes, nothing will happen because the triggers are the natural part of the transactions. And if you get an error in this transaction, it will roll back. So be careful while writing triggers. Test the user-defined functions individually. User-defined functions can be used in a query as field and user-defined functions runs line by line. So there are two parts for the performance of user-defined functions. One, individual performance of the user-defined functions, and two, row count and working count of the user-defined functions. If a user-defined function duration for one row is 1 second, then it takes 1000 seconds for 1000 rows. So we can't change the row count, then we should make user-defined function better. Our main point is must be user-defined function. Use table valued function instead of using multiple functions. Think about this scenario. We have a product table and order table. We want to make a product analyze. We have a few user-defined functions for product table which gets product ID parameter. For example, sale amount, sale total, min sale price, average cost, average sale price, average profit, etc. You can use a single table valued function instead of 5 or 6 individual user-defined functions. This is more effective and has better performance. We have a demo in this case too. Don't join views. If you have to, you can use temp tables. I talked about this case. Please don't join views. This is difficult to manage for SQL Server Engine. Don't bulk update or delete in big tables. For example, you have a table with 10 million rows. You have name surname column and you want to add 2 columns as name surname and want to update these columns by splitting name surname column. If you update these columns as bulk, it takes a lot of time and it locks the table, so other users can't select data from this table. There is another way. You can update all the table with a loop set by set. So according to this scenario, you can update your table by 1000 rows for each step. Your table will not be locked, users can select data, and your transaction log file won't grow. Don't join linked server tables to the local tables directly. Linked servers are very useful for querying remote data, but we are forgetting something while selecting data from the linked server. We are joining the remote table with our local table and expecting the same performance with the local table join. Don't forget, linked server is a remote server, and if you select data from linked server with an open query or open row set, it works with network speed. So if your data on remote side is much, then it causes the low performance. You must focus the decrease the data coming from the linked server. You can write a store procedure at the linked server and you can exec this store procedure to temp table. You can use open row set instead of open query because open row set is totally works at the linked server site. Prefer store procedure for frequently repeating queries because ad hoc queries are compiled before they work. If you use frequently repeated queries, it can cause a lot of compiling load and you see the compilation wait time on your server. If you use store procedure instead of ad hoc query, the procedures are compiled just one time and they run faster because it doesn't waste time by compiling. I have a real life story about this situation. You can't believe your eyes with the results. Please wait for the demo time. Avoid big character limit in varchar. There is a wrong information about varchar and varchar data types. People knows that varchar data type is useful because if the length of the data is short, it takes up less space. If it is long, it takes up more space. Therefore, there is no harm in giving more classes than necessary. So we can use varchar 1000 for name surname field. It is not a good approach because there is a limit for using indexes. If your varchar field length is more than 900, you can't use index in this column. The limitation is important, so please define the character length with your requirement. I think 50 is enough for the name surname field. Use set statistics IO on and time on. I talked about the importance of the read page count. Set statistics IO on gives information about the page count, and set statistics times on gives information about the duration and CPU usage. Because the SQL Server engine decides which index is useful for this query and execution plan by using statistics. So you must update your statistics at least one a day. Use fill factor indexes for frequently inserted, updated, or deleted tables. If you have a table which updated, deleted, or inserted frequently, then your indexes will be fragmented easily. If you don't want your indexes to be fragmented immediately, or if you want to save time, then you should use fill factor for these indexes.
This is ancient magic book, how to make queries ultra fast. And you know here's the Merlin, and you see the index and content here. Index management, query optimization, magic, server configuration, etc. Birthday query. I have a star from customers. It's the real American names and surname, but the data is not real. It's a fake data generated by me. It's about, I think, 7 million rows. Let's drop the indexes. Okay. Set statistics I on. I want to get the people who born today. Select ID, name, surname, gender, birth date from customers, where date part month, birth date equals 7, and date part day, birth date equals 19. And we have 5,000 rows, and this is the page rate. It's this is formula, multiple 8 and division. It's about 3 gigabyte data we are reading from the. But we can say that, so it is fast. Let's try. It is fast, okay, but just one concurrent user. What about the for 15 user? This is my trace, and this is my post stress test. Yes, ID, name, surname, gender, birth date from customers, where date part month equal 7 and date part day equal 19, and 15 repeat 5. It means 50 concurrent users run this query, and I run it. Is it working? The duration is 0. It's milliseconds. And now the duration is, 10 seconds. So the duration cannot be a measure for the cannot be only measure for the performance. So we should check the that is it working? Okay, you can stop. Why is it so slow? Because let's check the execution plan. It can't use any index. Actually, we don't have any index here. Let's create an index. For example, x birth date. birth dates. Now we have an index. Let's check. A little bit decrease it, but it is really so much. And using our index. But the right way, how can we improve this query? We can do this. We can create a date table like this. Let me show you. It's a time series table. I think we have 100 years date table. And we have year, month, day, month name, etc. So we can join these tables. And now we can use the birth date. And let's check the page reads. It is still so much because I didn't use the included columns. And now the read count is about 500. So let's measure the improvement 600 times faster than the before. Next demonstration, normal index or composite index. Get customers with filter, name, surname, start with David, and birth date is 1987, and state is Arizona, and city is Phoenix. Okay, let me drop current indexes. Now, the query is like this. Sorry, we have two rows, and this is the page count. This means it scans all the table. So we need some indexes, maybe individual or maybe composite indexes. For example, I'm creating these indexes, name, surname, birth date, state, and the city. And I will try these indexes individually, and let me check. For example, first index, name, surname. Let's check. This is really huge number. It is bad. So let's try birth date. Very good. And state. Oh, it is very huge. And city. It is very huge again. So we need a composite index. But what should be the order of the fields? Let's check. The name, surname, like David, as the row count is here. And birth date, the row count is here. And the state, Arizona, row count is here. And the customers, city, row count is here. The most important thing is the less row count must be the first order, because this is the less repeating values. So create index, a composite index, the name, surname, birth date is composite 1, and composite 2. Birthday is the first order, and state, name, surname. It's going on. Let's try with the IX composite 1. It's about 600. And let's try the composite 2. It's just 12. So in this query, when we use the composite index, our gain is, I'm dropping all of the indexes. Yeah, we turn the starting point, and our first value is this. And let's check our gain. It's about 30,000 times faster than without indexes. Okay, I'm finishing bulk update. Let's talk about the bulk update. Alter table customers. Alter table customers add name varchar 100 and surname varchar 100. And now I want to update the name surname column with this query, and you know it's a bulk update. Now I run it and changing other users selecting the data, and it's locked. You can see. So the system is locked. But alternative way, it's a loop, and I'm using update top 1,000 customers each steps, and I just 10 milliseconds waiting here, delay here. So update is going on, and other users working without any problem. It is valid for the deleting, bulk deleting or bulk inserted. Subquery, join, or UDF, which one we have to choose? I have a Walmart items. I have a table. It contains the Walmart products. Yes, it's about 500,000 rows, and I have a table order details. It's related with the item ID, and let's check the row count. You see the count function. It takes 2 seconds. Let me show the alternative way. This is an alternative way. Sorry, orders. It takes milliseconds. It's very fast, and it is very slow. So order details like this, very fast. Okay, I want to calculate some information about coffee accessories, and let me drop indexes. One way is using subqueries. It is very slow. You see, it takes 10 seconds. And let's try to join. It is very fast. So we can say that join is better than the subquery. Yes, it can be true. But remember that there is no absolute rule in SQL Server. There are always calculations and options. And we can use the functions, for example, get min unit price. So it's a basic function, and similar functions. And when we run this query, I think it takes at least 1 hour. So we can say that user-defined functions so bad, don't use. Maybe. Let's create an index because the order detail table, look at this item ID. I create an index for item ID. Let's check now. Now it is really fast, but it takes 1 second. An alternative way, creating a table valued functions, item info. These functions select all information with the other individual function in one time. So let's try it. You can see it is very fast. This is the other demonstration. Yes, I am. Okay, I want to share an interesting demo for you. Full text search. Do you use SQL Server full text search in your environment? Anyone?
Yeah, we do.
Are you glad for the performance?
I can't really tell, to be honest. I don't notice the difference. It's always on.
Okay. Oh, okay. T-SQL is very skillful language, and you can write your own algorithms, full text algorithms. For example, last week, I wrote my own vector search algorithm. Vector search is the newest and fresh subject, and it runs just the Azure SQL, and I can use it on-prem SQL Server with my own algorithm. And I want to use my own full text algorithm to you. I have a tables, Walmart items, for example, and I have ready file full text. This is the legacy searching. It's fast, but my server is fast. Reads is, yes, it's about 40,000 page. We can use the SQL Server full text, but this is my own full text algorithm procedure. It get the cache, and you can see the counts. And also in SQL Server,
I think I might have missed what you just did, Omar. So you said so.
Okay, exact search. You can see that it's very basic. I will show you. That's all. I can share code with you, but the way is so easy. What I did, this is the main table, and we have, for example, I think item name, which one? Product name. Yeah, this is the main field, and I separate this product name. Yeah, I separate these words to a table and insert to a table. For example, ID is 1. Yeah, select star from Walmart items where ID equal 1. This one. Select star from words where string ID equal 1. So this is the main product name. This is the words, and we can use in here indexes, and in my search query create a dynamic query like this. Let me show you. when I run, sorry, where is it? Close. This is the dynamic query.
That's an interesting one. I've never seen that done before.
Because I wrote it. It is better than the SQL Server full text search. I want to show the difference. For example, contains like this. Product name, I think like this. What? Okay. This is before. Quotes.
I don't think the double quotes are in there, right?
Not contains. I think this contains and Pepsi and cola, caffeine, etc. So this is the SQL Server full text. This is fast. Okay. We can use that like this. I think I should remove this. I couldn't remember. That's okay. No. Pepsi, cola, caffeine. What is the difference? I didn't remember. I couldn't remember. There is a trick here. We can choose the percent character in here, but we can't use the percent character in here. For example, we can see that we have 24 rows with die, but like this, we have 0. Let's try my algorithm. For example, it's okay. For example, it's okay. For example, it's okay. And it is really fast. I can share the algorithm to you. And I am finishing. I'm sorry. I think we have a little problems. We had a little problems.
No, I think your demos are great. If you got more, I think people are interested in seeing them if you have time.
Yeah, please don't feel rushed, Omar. We'll stick around as long as you can go.
So should I go on?
Sure.
Yeah.
Let's look at the legacy times. Our procedure is a real lifesaver. And traditional knowledge is always valuable, says our wise bird. Let's look. It's a real life story. Vehicle GPS tracking system. I have a friend who works and who managed the SQL Server of a company who produced the vehicle GPS tracking system. The system works like this. Lots of cars have GPS module, and they share their GPS information to the cloud with web server 1, web server 2, 3, etc. And it is written to the SQL Server database. Let's look at the numbers. We have a vehicle status table, plus status table, and this is the sample table. We have about 200,000 vehicles, and we have 200,000 rows in SQL Server. So 200,000 vehicles updates every 10 seconds. It is a huge update. Yeah, it means 20,000 updates per second. So it can cause any problems. I'm sorry, this is now daytime, and let me check my camera. How is it going? I don't know, because when we started, it is nighttime.
It is bright now behind you.
Right. Just a second. Let me close my certain.
Oh, I thought I made it.
Eric's dream to have automation in his blinds.
Nice.
I think it is better. I'm sorry for the darkness. It's not my fault. This is the simulation of the system. So we have a problem about the frequently updated table. So this is the profiler. They use ad-hoc queries and updating 200,000 rows vehicle table by ID every 10 seconds. And this is the CPU utilization with 38 cores. It's system working at 90% CPU usage. And the problem is the system is using so much CPU with 38 core. Yes, we can see the matrix 38 core with ad-hoc query, and you can see the CPU usage. And when we look at the resource weights, we see that compilation weights so much. This is the problem, because the ad-hoc queries are compiling every time before they run. I advise that please change it to the store procedure. And let's check the results. Yeah, this is the average usage of CPU and the average network usage. It's 100, 200 megabit per second. After changing the ad hoc query, the store procedure, you can see the store procedure here. And be ready. This is the result. This is the CPU usage, 10%. And it's not finished. Remember that we had 38 cores, but this just 20 cores. Yes, the average CPU usage you can see here is 10%. So oldie but goldie, legacy is the best. Store procedure, save your lives. And AI, the most popular topics in our lives. And I'm using AI in my SQL Server optimization, query optimization. So you can check these domains, SQL Server.ai and Azure SQL.ai. These are my own domains, and this is my own GPTs at SQL Server. Yeah, by Ömer Çolakoğlu, you can see here. So let's check it. For example, I open my birthday function, birthday query, and I copy here. Hey, buddy, this query is killing me. Tell me why it is so slow. Here is the query. Produce alternative solutions to me. And can I use time series table with this partition? I think it is not necessary. Time series table, no. I think it's a bad solution. Sorry. Let me share the execution plan with you and tell me and advice. I'm going to here, and I think this XML and paste here.
Don't trust it. It's going to hallucinate.
Actually, I use it in Turkish. I can say that Turkish advices are more successful than the English. This is first time I'm trying to English. And in my Twitter account, I'm sharing with my solutions. You can see the scenario here. So, as a summary, you can use your own GPTs, and in here, explore GPTs here. For example, I wrote SQL Server Expert, DB Assistant, like this, and this is my own GPT. So be ready to use SQL Server with AI.